back and let's see what's next. All right. So we have the menu. We know that the menu is working. This is the easy part. Okay. So the best thing to do is to start to work on adding player information, right? Because without having player information in the system, we will not be able to actually do anything else. So we have to know what information we're storing on a particular player. So let's just kind of take a look. We established that we're going to have two files. We'll have a player file, and we'll have a file with we have a player file, and we will have a file with some information on the player's payments. Okay. So what information do we want on a player? Let's kind of just come up with the files. So if we have a player file, let's say we want to keep some information on a player. What do we want to keep on a player? We might want to have a player ID, because each player should have their own number to identify them by. Okay. A player should also have a what? A first name. A player should have a last name. A player should have a date of birth. Okay. So we could do two things with the date of birth. We could either choose to have a struct for date of birth, or we could choose to have a, to store it as a string, or we could store it as B_day, B_month, B_year, which might be the best thing to do. Right? And let's talk about the data types for these things as we go along. An ID. What might be the best ID for a player? In terms of data type, that would be an integer. The first name, be a character array. Last name, a character array. The birthday is an integer. The birth month is an integer. The birth year is an integer. All right. In terms of the player, there we might want to keep information on their position. The position is a what? Character array. Okay.
Yes, sir.
Any other information we want to keep right now? No, let's keep this simple. Okay. You guys could get fancy when you go ahead and do your what you call it, your own SBA, right? But I believe in the KISS principle. Let's keep it simple, stupid. Okay. So the next thing that we want to store information about would be payments. And payments would also have some sort of struct that is associated with it. Okay. We want to know who made the payment. So we say player underscore ID for the payment. That should be an integer. We want to know the data, the month and the year of the payment. So pay underscore month, pay underscore year. Okay. And these would be integers as well. We want to know the amount paid, right? Or let's say maybe the amount due. which could be a float or a double or something so, and the amount underscore paid. It should also be a float because those are financial values. The thing is, we'll come to payment a little later on. So we just, for now, payment is just kind of like an idea. All right? We want to study about sorting some, saving some information for a player. So we get this information on the player. Allow me to just copy it somewhere so that, oops. Allow me to just copy it somewhere so that I can, when I pull it out, I could still have it to read when we creating this struct. So we want to create a struct for a player. I like to create my structs pretty early on. So we have type define, right? Struct P. We'll name this data type player. So what do we want to do with this player? We want to be able to store an ID, right? So int ID, a character array of called f underscore name, right? That could be about 30. A character array of L underscore name, that could be about 30. Right? The birthday, int. Int B underscore month, int B underscore year. And their position, which is a character array, right? Generous. So this here, this is the blueprint for the player struct, which we will use to store information on all players that we read and write to our files. Okay? Here's how I kind of think that the system will work. And I feel like if this is the easiest way to go about it. All right? You have information on players in your file. So you have player 1, right? So you have player 101, which is John Doe, ... 102, Jane Doe, ... 103, right? Jim Dean, ... 104, right? Lyle Smith, ... 105, Jane Jack, ... When we read this file, so this is the players file. So we have players.txt. We will read all of the data from this file into a struct array of players that we could manipulate once the program is running. So this is of type player, and this is the list of all the players. And you know, I represent my structs using little circles. I don't know why, right? I just like to represent the structs with circles. So this would be John Doe inside of here. This would be Jane Doe inside of here. This would be Jim Doe inside of here. This would be Lyle inside of here. And this would be Jane Smith inside of here, or Jane Jack, sorry. inside of here. So all of the different players will get put into my player list array. Once I have this structure in memory, this array in memory, I could do anything with it. If I want to add a new player, based upon the sequence of players, I could generate a new ID, right? If I'm trying to find a player inside here, I could search through everybody inside of here and say, okay, what name am I looking for? I'm looking for Lyle. And we're going to do this, eh? I'm looking for Lyle. Is this Lyle? No. Is this Lyle? No. Is this Lyle? No. Is this Lyle? Yes. So I'll return Lyle to wherever I have to return him. Okay? If it is that I want to remove somebody from the array, I will then load up everybody from the file. I could see who I want to remove. I could remove this person. Let's say Jim is no longer with us in the club. And I could write back the players.txt everybody except Jim. So we'll end up with John, Jane, Lyle, and Jane again, right? Jane D and Jane S. Because once we have the data in that memory structure, we can manipulate it as we please. And later on, when we start to look for payments, we're going to go matching names of players against the names of persons who made payments or who didn't make payments, etc. So I could see what months who didn't make payments for. All right. What I'm giving you, what we're about to do here, what we will do is something that is a little more advanced. It's not going to happen all in one day, right? And I really want you all to try and be in school by 12:30 on Wednesday, because we need a little extra time, okay? I really wasn't able to make class last week Friday. I had some real, important stuff to deal with, and so we kind of a little behind. So I had to make it up where I could, all right? And then on the 16th, we're not having class because we will be doing the Canadian computing competition. And we will be in school doing that together. Okay? So if it is that you're not doing the competition, then that is some time to start working on your SBA based upon what we know. All right? Well, let's not worry about the future. Okay. So in conjunction with this, we are also going to need a file. What I do, however, is that in terms of this player list that I create, it's not the best thing to do from a programming perspective, but you all will get away with it because you all are beginners, is that we make this variable global. And global means that this variable of the player list that we create will be accessible by every function within this program. I spoke to you all about global and local variables already. Did I? The term sound familiar? Huh? Clement?
I think so.
You think so? All right. Let me just recap. Okay. Just to recap, just to see. Global versus local variables. When we are using functions, let's say, for instance, we have int, not int name. Let's say, for instance, we have include ... right? Int mean. And we have int opt ... And I have outside here int num is equal to 5, right? And then down here I have my menu function, void menu. And then I have int opt. And I continue on. These variables here, this here, and this here, these are local variables to the function that they were declared in. These are two separate variables. This and this are two different variables. One is, you can think of one as main OPT and one as menu OPT. But this num variable up here, because it was declared outside of a function, it is accessible by all functions. It is global. And we could manipulate that in certain ways. Okay? And we're going to see it here with the player list. We're going to create a global array of type player so that all functions in this program will be able to access it. Now, later on, when you go and you learn Java, right? And even when you learn a little more advanced C++, you are going to have your lecturer shouting at you, do not use global variables, they are unsafe. And I'm telling you that they are correct. But I am also telling you at this point, because you are now learning, right? And there are certain things on the syllabus that we do not do. It is not easy for us to get around using global functions. So it is okay at this point. But don't go forward to your university lecturer and say, well, Mr. Valdez said we could use global variables whenever we want. Right? Don't call my name like that. I will find you. I know when they call my names, right? so, you know, sometimes I don't want to be 3 years down the road, be like, you know, what in the world, boy, said? Why is that calling my name like that, right? No. Right? This is a step towards greater knowledge. This is what we have to do now. So I am telling you, okay, we're not going to abuse the use of global variables, but we will use them where necessary. Okay, so we can say player what? Player list. I like the variable name list when we have to list out something. And we can make a list that could hold up to 250 players. What use is this? Well, this will allow me to add players to the system. It'll allow me to store players into my file. So I also want to have list underscore I, which stands for the index, and I'm starting this at 0, right? The index, do I need it to start it at 0? No, I don't necessarily need to start at 0. Index that manages the player list, all right? So this is the variable that will hold all the players' information. I'll excuse me again, I in a separate room and my children are by themselves. My wife had to go out and teach today in person. So I'm going to just check on them and make sure they're fine. So give me 1 minute, okay? You can sit down, watch this, and soak it in. Thank you. I have the approval of Clement. All right, I'm back.
Excuse me, sir. I have one question.
Yes.
So you said player list is needed to hold all the players' information, but why do we need players? Because we're adding a new player with all the information relating to their date of birth and their position.
Ola, just slow down and ask the question again because it was coming in a little broken up.
Okay, no problem. What I was asking is that you said that you hear me now?
Yes.
Okay, so player list is the one that will hold all the players' information, but it's not holding all the other information such as date of birth and position. So if we were to want to add a new player, how would this be helpful?
Player list does hold all of this information
How?
because it's a variable, an array variable of type player, and player is defined as having these elements. So every index, every position inside of player list will have ID, first name, last name, birth date, birth month, birth year, and position. All right, let's take a look at it, right? Next step, and this might make it clear to you. I am going to create a file and put some test data inside of it. Okay? I'm going to create a file and put some test data inside of it, and we will read that data into player list. So let's start off with Notepad. And we have ID 101, comma, first name. Let's use people from class here, right? Let's start off with Ola. All right, let's say that Ola is born on the 15th of the, let's go 15th dash 7 dash 2005. I don't know when Ali was born. Is that around the year
So
that
you
you
have
all were
everything
born?
correct? You have everything correct except the date.
Except the day?
Yeah, it's 13 instead of 15.
And you know, all these years I do this, and I always hope that I get one right on the spot with the birth date. Right? I never guess anybody birth date yet, but this is the closest I've been. Now, what position you want to play?
So this is football, right?
Yes. Oh my God.
What are the positions in football? A keeper?
All right, let's make you a goalkeeper.
Midfielder, say. So I play midfielder.
Clement, what was that?
No, she want to play keeper, say. Like that.
All right, 104. All right, well, let me just go up in order. 102. All right, let's go with Clement. EMMENL. All right, let's give Clement, just my psychic powers are telling me that Clement was born on the 27th of the, Clement, am I correct? 6, right, 2005. Clement, am I correct?
That was real off, say. The 8th
What?
of the month, the 8th of the 12th month, 2004.
You know, something tell me you was a December person.
Say, it's because I said in class before, say.
Uh-huh.
Yes, say. Say, I want to be attacking midfielder.
Fielder, right? Right. All right. Make you a center attacking midfielder. We have 103. Right. And I just put in 3 persons inside here. And notice these commas are very, very important, because these commas are what we're going to tokenize by to read into the struct. Okay? I'm not lying to you. Today, I'm sorry for whoever I have after lunch, because today might be one of those days that your head walk away with, hurting after class, right? This might be a little intense, but honestly, the thing is, it's only intense the first time, and then afterwards, when you get a little more used to thinking like this, it actually becomes quite easy. So we have Keon and yes, Real.
If it's tokenizing by a comma, will the date of birth be a string, sir?
We'll see. We will see. We don't need the data to be a string. We can manipulate the data as we see fit. That's the power we have. Keon, did I get it?
Unfortunately, it was very far off, sir. The 4th of August, 2003.
The 4th of
August, 2003.
2003.
Mm-hmm.
See, I
Keon,
think
what
it should say
position you playing?
4 and 3, say. Most people
So I'm
want us
playing
1 3.
midfielder, sir.
He wants to be a what?
A midfielder.
All right. Left or right?
Right, sir.
All right. All right. I just put in a two-letter code, so GK. All right, or a 3-letter code. And then we will save this. So we'll save this as players.txt. So we have some data inside of here, and we want to now put it inside of this struct. Okay. Actually, I might go ahead and do the let's add another option. Let's add an option to so I'm adding this as 2 now. Printf, because this is kind of important to do too. view all players. Okay. So we have an option to view all players. So we change this to 3, this one to 4, this one to 5, this one to 6. Okay. So to do view all players, this is 3, 4, 5, 6. All right. So 6 is now the option to exit the system. Okay. This is an integer list I, right? So, right. So we have our players stored in a file. We have our players stored in a file, and we want to view all of the players' information. And the thing is, we don't just want to view the players' information from the file. We want to store it into the player list so that we can view it from the player list as it is read. So the thing is, we are going to need a function to read the data into player list. And this is where we get another 2 functions. We get, as I said, because if you look at my strategy here, if you look at my strategy here, we said that we're going to read data from the file into the struct, manipulate the struct as we see fit, and then write data back to the file. So no matter what we do, it's always read the file information, do what we have to do, and then write back data to the file if necessary. Okay? If we're just doing a view, we don't need to write back to the file. But if it is that we're doing an add or an edit or a removal, then we will have to write back to the file. And this is because I want to keep it simple. Everything in our computer system is input, processing, output, and manipulating storage. Let's follow this principle. If we have to add a data, right, we read the file, we ask the user to get the person's information that we want to put in. We add it to our player list, and then we output it to the file. Input, processing, storage, output. Okay, and this is our this is our thinking about it. If you can master this, then you can master variations of it when you go out there in the working world and people ask you to do all kind of special stuff with data, etc. Okay, but we want to know today's objective is just to be able to view all persons, and hopefully we'll be able to add a person as well, and that this player list allows us to do that. So let's see if we can now come up with a function to read all the data into player list. Okay, so we could add this to our list of functions, and we could see, what do we see? We see that, remember that list is global, eh? All right. So we can say void read players, right? And we don't have anything inside of there for now. So we just have a function called read players. So we also want to have this function where we have to, where is it? Where we view all of our players. Okay? So we're doing where we're viewing all of our players. So we're taking out the to do, and we calling our function view players. So I have to now create a function called view players as well. Void view players. Okay, so I just created 2 more functions, read players and view players. Read players and view players. Do either of them exist? No. So I have to go and create them. Void read players void view players. And these two functions are very simple. Sorry?
I think in line 82 it's supposed to be capital P, right?
Oh. Right, read players and view players. Both of them are similar, except when the thing with read players is read players specifically read players into the struct. View players is to display the contents of that struct. So actually, view players is going to have to call read players. Okay, view players is going to have to call read players. So let's see if we can read some information. We have file FP. We say FP is equal to fopen for players.txt. How do we want to open it? We want to open it as a read. So open the players file to read. We verify the file if FP is equal to null. What do we say? We say printf the players file could not be read. Please contact your administrator for help. And we put that because we want to reference that at some point in the what you call it, in the documentation that we'll have later on. Okay, we do a get char, and then we say exit 0. So we can't go forward. We cannot go forward, right? Now we have to call view players. We could call view players through the menu here. And only through view players could we get to read players. So if we want to test it at this point, we would say read players, which would load the file's content, right, into the struct array to display. Is it doing that yet? Not fully, but we just want to be able to test it and make sure that the file being read. So if I select 2, view all players, they didn't give me any error message. That is actually a good sign. Because if at this point, my players.txt file, right? If at this point, my players.txt file, let's say for instance, I put an extra S here, then maybe it mightn't be found too. The players file could not be found, right? Contact the administrator for help and the program stop. Okay, so we know that this is working up to here. Once the file name is correct. Are you with me? Good.
Yes, sir.
So, yeah, Real?
No, sir, just telling you we were there.
Okay, good. So we say the player's file could not be read. We want to contact the administrator for help. How are we going to read this information in? Let me open the file so that we could see the data that we'll be reading into the file. The first things first is that we have player list. We know that we have list underscore I is equal to 0. Start the index positioning at 0. Now we want to read data from the file. So we want to say right? While n equal to file and the file for FP, what do I want to do? I want to read in a line of text from the file. So I need a line. So I'll say char line, right? 300. Now I'll say F gets what? Line 300 from FP. Read in a line of text from the file. And alternatively, this is one of those situations where you can use fscanf. But Mr. Valdez don't like fscanf. Mr. Valdez out to make all your life difficult, right? Because Mr. Valdez find, hey, this could be an easy fscanf reader, but Mr. Valdez just prefers fget and converting his data manually. Why? Because, you know, the guy wicked, okay? He don't sleep. So, you know, he just spend time sitting down thinking of ways to terrorize his students. All right, and I'll have video proof of that right now. So Mr. Valdez knows that if it is that you use fgets, you have the possibility of reading in the new line character. So we have to say if line at position strlen for line -1 is equal to a \n, then you wanted to put line at position strlen -1, right, to be a \0. So what does this do? This says if the line read has a \n as the last character, make it a \0. Okay?
Say by chance, do you have the string library?
No, I don't. I didn't put it in. So I know that I have to put it in. Okay. All right. So that this will, we press compile, we have no errors, so our code looks solid so far. Now we want to start to tokenize. So we know that we also need a token to store that. And it must be represented, not here, sorry. It must be represented as a character pointer. So we're going to tokenize, and we know that we have to tokenize certain things. Look at the file. We're going to put in this here. This has to convert to an integer. This has to convert to, well, it had a copy. This had a copy. We have to convert these to integers from this string. So we're going to actually tokenize this token, and then we will copy this into position. Okay? It's not as hard as you think. We're going to do it. I'm going to give you all this code. You're all going to be able to take this and run with it from there on. But I don't want to see my code given back to me. And I know how to tell the difference between when some of you all take my code and selling it back to me, and when some of you all edit my code in a smart way to make it yours. All right? I know my programming style. Don't just change some names and everything is my own structure. I want to know that you write your code using this as a guide, rather than you say, well, let me change line to LN, and let me change players to footballers, But then it should be appropriate to your scenario. Some things are going to overlap and some things are not. All right. So, and just now you're going to get a break again, right? Because I have to check on those girls. But let's see if we could read in a line and tokenize it. So we'll read in a line And we will say token is equal to strtok line, comma. The first one, we always have to get the, this should be the ID from the line. The first one always has the name of the variable. And if it is that we know that this is list at position I dot 0, where do we want to put it? We want to put it inside of the actual players list. Here, we want to put it inside of the players list. So this is where things get a little nice and dicey. We will say that list at position list underscore I dot ID is equal to A2I token. What is this line doing? This line takes ID that is stored in the token and converts it to an integer and stores it in the appropriate index position of the players list. That one line doing plenty thing, boy. Right? It take the token, it convert the token to an integer, and at the proper position inside of the player list, it store it in the player's ID. Look at that. I don't find this line as a thing of beauty. One line, it doing about 4 things. Right? It converting, it finding the position, it's storing. I like that. Okay? Clement, you all right? Your head hurting?
Say, you lost me with this one, so. And
all right.
So list I
so
say,
here's what we did.
Incrementing say.
Huh?
The list
Here's what
underscore. Say I'm not seeing it incrementing. So.
No, we're not incrementing yet. This is just for the first position. We will eventually increment list at position I. Okay? So we had the first player. The first person was Ola. And we take this, oops. We take this line and this here was stored in line. Right? So we take this and we store it in the variable line. And we then tokenize lines. So then we take this and we pull it out and we see it to put it in this array that we have here with a bunch of structs. And we have the ID part and we say take that 101 and convert it to a number and put it inside of that 101 there. This is still at position 0. We here move up. So this here is represented by list at position I. Okay, we pull a line of text from the file. We tokenize the first piece of information. We convert it to an integer and we store it in its appropriate position. Cool? Don't make it more than it needs to be. Okay, right. So we go on now, and we have to do this for the other elements of the list. So the second thing that we have to pull is the first name and the last name. I think I named them F name and L name. So again, it's the same thing, except, right, we go, token is equal to strtok null, comma. get the first name from the line. We can say list at position list underscore I dot F underscore name, right? And we want to copy what? We want to copy the token into here using strcpy. So copy the first name into the struct. Last name would be very similar to this, except that instead of first name, it would be to get the last name from the line, and you're storing it in L name in the struct. So you copy the last name into the struct. Then what comes after the last name? The date of birth. The date of birth is a little special because we're going to have to tokenize the token. Okay? So we're going to, we could do one or two things. If you want to do it the easy way, which you could in this case, right? We could actually have this like that. Actually, let me not hurt your head with anything extra. So I will allow for the data to be tokenized straight in, just like how we did the ID, right? So the next thing is to take the token. So we get the birth, date of birth, day from the file. So we get the date of birth, day from the file. And then we do the same thing like we did up here. We say list at position list underscore I dot, what did I name it? B underscore D. So dot B underscore D is equal to what? Is equal to A2I. So the date of birth day. And we do that same thing for the month and the year. So this is the month, right? B underscore month. Store the date of birth, month. And then we do the same thing for the year. Year, get the date of birth, year from the line, and store the date of birth, year. And again, because the last one is a string, position is a string, right? I'm gonna try and keep that, carry that down to 10. So position is a string. It will take pretty much, it'll look like how first name and last name looked. So you have to use your string copy, position, right? Copy the position into the struct. And token is equal to string talk. Get the, oh, sorry, I copied it back to front. Right, so we get the position from the line, which should be the last thing that we need to copy, and then copy the position into the struct. So we have to put this into position. Okay, and the last thing that we do is that we say list underscore I plus plus. So once this is finished, it would have copied everything into the, player's file, into the struct, right, from the player's file. So once you call read players and that struct gets copied, remember that this player's variable, this player's here is global. So, and also list underscore I is global. So that makes it easy in terms of viewing players. So we could say int I, and we could say for I is equal to 0, semicolon, I is less than list underscore I, semicolon, I plus plus. Okay? So for all of the players red, right? For all of the players red, we want to display their information. We want to display their information. And how are we displaying the information? We have to print it out accordingly. We could print it out in any order we want. Okay, so I could say printf what? Printf %sign D colon %sign S %sign S, right? And %sign S dash %sign D dash %sign D. Sorry, slash %sign D slash %sign D. I changed the way that it's displayed. Okay. So what am I showing first? I'm showing list at position I dot ID, comma, list at position I dot F underscore name, comma, list at position I dot L underscore name, comma, this is their position, list at position I dot position, comma, list at position I dot B underscore D, comma, list at position I dot B underscore month, comma, list at position I dot B underscore year. And this will display everybody's information. Let's see if, right, I had a semicolon missing here and here and here. What do I have missing here? Yeah, had 2 E's inside of it. And somehow I forgot my comma right there. Okay, not too bad in terms of having errors. So if we say view all players, we need to have, of course, a get char. Oh, hold on, please. Hey, sorry. Yeah. Next time, come and tell me, okay? Okay. My class. Right, so let's check and see if this works. To view all players. Hey, we got the information, reading from the file, and we're listing out the information. So it worked. We took the information from the file. We could see that it's not in the same format. So it means that we read it into our struct. We read it into our struct, and then we manipulated it in terms of how we want to display it. If we could manipulate it in terms of displaying it, it means that we can manipulate it in any way we want. because we have the data inside of a structure in memory. Okay? Allow me to take 2 minutes. I'm going to pause the recording. You all take a little break. Well, actually, we'll come back in 10 minutes, and then we will see how we can add a new player. We can add a new player and write that new player's information to the file. Hopefully, we could get that done in the half hour we have left. All right? Is this so bad? Let me just ask. Let me check. It's not that bad, right? And it's there. This information is available. Huh? Clement?
See that in that bad, sir.
Right, it's not too bad. So just give me 10 minutes. I'll take 10 minutes. Take a little breather, soak it in, and I will be back.